All right, so now we'll jump to example one, just trying to identify whether something represents inverse variation or direct variation. So let's see, we've got xy equals -2. And remember, if we can write it in this format, some number times x, that's going to be direct variation. And if we can write it in this format, some number, I guess I used m for slope. I think the book uses a. If we can write it as some number a divided by x, well, that's going to be inverse variation. And in this one, example A, to solve for y, we'd have to divide by x on both sides. And you get y equals -2 divided by x. So we wrote it in that form, some number divided by x. So because xy equals -2 can be rewritten in this form, we would say this represents inverse variation. And remember, the constant of variation is that a value. It's whatever number gets divided by x, which in our case would be -2. If we jump to example B, if we were to get y by itself, we'd have to multiply both sides by 4. They'd cancel out. We get y equals 4x. And since that's in this format, right here, some number times x, so since it can be written in the form y equals a times x, this would represent direct variation. All right, you jump to checkpoint problem number 1. Go ahead and hit pause in the video. And when you're done with these three, why don't you come back and check them. For number 1, you should have multiplied both sides by -5. And you get y equals -5x, which would be direct variation. In number 2, you don't just have a number times x or a number divided by x. Because of this -1, this kind of ruins everything. This is neither direct or inverse variation. And number 3, if you were to get y by itself, you divide both sides by x, getting y equals 8 divided by x. So we've got some number divided by x. It fits the pattern of inverse variation.